All right, so we're going to talk about the complex. We're just going to continue what we were talking about in the last video. It was this stuff, right? We were talking about complex inner products and kind of a new geometric intuition. So in this video, and the video in this video, we talked about scalars. So we're going to talk about if there's more than one component now. And with this geometric intuition, it's actually easiest to do with complex components rather than real. So we'll do it with complex, and then I'll show you what it'll look like in the real. So yeah, let's go for it here. Yeah, so now we're gonna have so vector 1, and then we're gonna inner product it with vector 2. So how that'll look is like this. So we're going to write it like this. So we have A1 plus A2I, and then B1 plus B2I, and then we're going to dot that with C1 plus C2I, and then D1 plus D2I. So you can see now we've got two components, right? So here's component 1, here's component 2, and here's component 1, and here's component 2. Contrast that with the last video. It was just one component and then just this component. So now we have two components in each vector. So what we'll do here is so we'll just take them one component at a time, right? So we'll look at this component and then this component, right? Because when you're doing this, it's basically component 1, so A times C conjugate plus B times D conjugate. And basically what's happening is this is what we talked about in the last video. So we're going to do that one, and then we're going to add, and then we're going to do this one, which is also basically what we did in the last video, but with the second component. All right, so let's draw A and C. So here's A, and then let's do C, right? Okay, and then remember how we did this. I'll draw two copies of it. And 2, and then 1, right, like that. So remember, to do the imaginary component, we just do the cross product, right? So to do the cross product, you drop this down, you just complete this rectangle, right? So now you have this area is the imaginary component. And then we said to get the real component, you're doing the dot product of these two, which is the same thing as rotating this by 90 and then computing the cross product. So I'm going to go ahead and rotate it by 90, and that's going to be over 3 and up 2. So that's this vector is that one rotated. And so now we're just going to draw this square, right, like that. So this is the imaginary component, and this is the real component. So now I'm going to stretch it to be a factor of one side of length 1 right here. And remember, this is imaginary, and then this is real. All right, so imaginary, we go up. I'm going to say this is about 2 by 4, so we'll call it like 8 or so. I'm gonna draw that over here, okay? Let's make sure everyone can see. So that's about 4. That's about 4. So this area is the same as this area, right? And I think this one is actually about the same size. In fact, it might actually be. But so we'll do that again here. So that's 4. That's 4. So now we have just like this. Then, so your first looks like that, right? So now what we said is, so that's AC right here. And so all we want to do now is add BD. So let's say BD looks something different. So let's say right here and then right here, so B, and then D. Now we just do the same exact thing, right? So let's go ahead and do this cross, which is going to give us the imaginary component, right? So this area. And then let's rotate and get this one. And then I almost forgot what I drew there. So now we've rotated B by 90, right? And now we're going to compute the cross again. So this is the real component. All right, so what are we going to call this? This is just about a little over 2 by 2, so we'll call it 6, and that's real. And this is imaginary. So I think this is about 6, and this is about 4. So let's do 4 in the imaginary direction. All right, like that. So these two kind of go together. And then I think we said 6 over here. That's 6. All right. So now we get this. So this vector is this vector. So now to add them, all you have to do is just basically draw the same picture, but starting here. So now we say 4, and then 6, right? So it's this vector here. Boom. So now your overall inner product is this vector. And that's the whole thing. That's kind of the final answer, right? And then, you could do it the other way. You could start with this one first and then add that one on, because it's the same thing. So I said we would do it with just real vectors as well, right? So you can imagine if A and C were only real instead of imaginary, you would just have one here and then another one there, right? So I'll actually, let me grab another sheet. So if we have v1, 1 dot v2, and they're real, then what we want is, so then we have a1 comma b1, and then c1 comma d1, right? So we're actually going to do the same thing we did, and I'll actually bring this over here just so you can kind of see, right? So we want AC plus BD, right? And so the way we do this, so A and C, these are just real values now. So, let's say A is 1 and C is 3, right? We're going to do the same trick that we talked about up here, right? To do these inner products, you can just rotate 1 by 90, right? So now let's rotate A by 90. So we're here now. And now this area, that's the real value. And, we said it's the same as the complex case, so let's draw them here. And do you remember how we got the complex value? What did we do? We took the cross product here, but the cross product here is 0, right? Because you don't have any perpendicular component. So that's why you get 0 as the complex value. And now we'll do BD, right? Let's say B is 2 and D is 4. That's probably a mistake because it's going to be big. What's their cross product here? Well, it's 0, right? If you had some perpendicular component, you could draw a box, but there's no box here. So the imaginary is equal to 0, right? And now we'll do the real by rotating it 90, right? We rotated this one 90, and then we kept this one. So now our box is 8, right? And then we can do our little stretch that we're used to doing, right? So 2, 4, 6, 8. It's right here. Perfect. So now we have this as a real value and this as a real value. And just like in this case, you draw one and then you draw the other connected, right, from the end. So now we're drawing 3, And so that's our vector, right? Because we have 0 this direction, so it's right here. So now we start again and we draw 8. So that's 4, and that's 4 more. All right, so now here's our new vector. That's 11, right? And the imaginary component is 0. And this is the final answer. And so let's check to make sure using our just how we're used to doing it. So A was 1, right? And then A was 1 and C was 3. And then here we had B was 2 and D was 4. So now if we multiply these, we have 1 times 3 is 3, plus 2 times 4 is 4, 3, or is it 8, and so 3 plus 8 is 11. So again, the geometry works, and it kind of all comes back to doing it in like this complex case. And then yeah, you could do it for many dimensions, right? So we did 2 dimensions here, and it was just like this one plus this one. But if you had 3 dimensions, you would just do this process. You do it 3 times, and then you draw your first one like this, and then you draw your second one like this, and your third one like that. It's that easy. And one thing I haven't shown is if things are negative, right? So if they're going the other direction. But that's something you can work through. So these areas are always positive, but if they're oriented the other way, then the area, you consider the area to be negative, and then so the arrow would go the other direction. But yeah, that's all there is. Thanks for watching.